Okay. So what do we have here? This is called a what? Bar model. So we know that the product is 24. Remember, product is our answer. And to figure this out, we figure out how many times does a certain number repeat. So how many times does this 4 repeat?
6.
Yeah. So 6 times as many as 4. So 6 times 4 repeats. If it was 4 times 6, what number would be repeating?
6.
The 6, yeah. The 6 would repeat how many times?
4.
4. So it would look something like this. And we would put a 6 in the box. So this represents 4 times 6, and this represents 6 times 4. Okay? Make sure you have this down in your packet. Show me 2 when you're ready for number 2. Okay. Which statement describes this equation? So before we even look at any of this, let's figure it out for ourselves. We have 6 times 8. What number is repeating?
8.
8 is repeating how many times? 6. Okay. So 8 is repeating 6 times. So it's going to be, we have to figure out which ones it is. It's going to be, we're looking for something that says like 6 times as many as 8. So we have A, we have B, and we have D. Okay? It's not C because it says 8 times as many as 48. Are we multiplying 48? No. This says 6 is 8 times as many as 48, so it's doing 8 times 48. Is that what we have? No. Okay. So my correct answers are A, B, and D. And if it helps you, write out the equations next to them. So 48 is 6 times as many as 8. Remember when you see the word is, there's like an equal sign there. Okay? So if it helps you to figure out these problems, write your equation next to them.
Miss Cornell, A says 48 is 8 times as many as 6.
What do we call it when it is, it's not talking about bar models, but what is it talking about when we can switch around the numbers? Not opposite operation. Annabelle? Fact families. Okay. But if it's specifically, if your question specifically has a bar model that you're referring to, then yes, you're right, Erin, that would not apply. But in this case, there's no bar model. It's just talking about this equation. Okay?
All right.
Thank you. Okay, show me 3 when you guys are ready to switch over to number 3. Okay. So we have a table and we have a empty, what is this called? Bar model. Good. So it says the table shows number of cards 2 friends have. Ben has how many cards? 7. So what do we put for Ben? 7. And Dan has 5 times as many as Ben. So 5 times, how many did Ben have? 7. So what number is repeating down here? The 7. It's repeating how many times? 5. And what's 5 times 7? 35. Okay, this is the equation we have. 5 times 7 is 35. And so this question on B is specifically referring to this bar model, right? So which equation represents the number of cards Dan has? 5 times 7. So which would be our correct answer? B. Why would C not be our correct answer? It's adding, good. Why would D not be correct? Correct. And what about A? Go ahead, girl.
Different number.
Yeah, it's multiplying by 6 when we have 5. Mm-hmm. Yeah. Good job, Annabelle. Okay. Give me a thumbs up when you're ready to go to number 4. Good. If we have time, we're going to do some whiteboard practice too. We should probably have time. All right. We are moving on to, so your 2 standards masteries tomorrow is going to be on bar models and equations. And then your second one is going to be on the box method. Box method. Write that up top. Okay. What I want you to make sure that you do tomorrow is that when you have a question, first ask yourself what it's asking you to do, and then make sure that you work it out for yourself before you look at all the answers, okay? Because all the answers all the time are going to try to trick you. But if you have your evidence over here, then you won't get tricked, okay? So, decide if each expression can be used to solve this. Choose yes or no. So what are we going to do first?
Solve the problem.
Yeah, solve the problem first. But is it asking us to find the final product?
No.
No. What is it asking us to look for? The partial product. Okay. So let's draw our boxes over here.
What if we
So that should be okay as long as you got your partial products. Aaron, make sure you're on mute, please. Thank you, Christian. Do you remember what this part is called? Rewrite it in what form? Expanded. Good. So, what would be our equation here? 3 times 4,000. Then we have what? 3 times 200. Good. Do we have anything here? No, because there's 0. Then we would have, what's our last equation?
3 times 7.
Okay, cool. So we have all of our partial products. So we're going to come over here and we are going to compare them. So this has 4,000 times 3. Do we have that? Yeah, so I'm going to put a check. Do we have 200 times 3? Yeah. And do we have 7 times 3? Yes. So does A work?
Yes.
Mm-hmm. Good. Do we have 4,000 times 3? Yes. Do we have 20 times 3? No. So this one is false. This does not work. What about 4,000 plus 20 plus 7? No.
Wait, that actually works because I have times 3 of that. No, because it's 20 instead. Oh.
Yeah, good catch. You gotta look at all those digits. 4,000 plus 200 plus 7. Is that what we have up here?
Yes.
Yes. So does D work?
Yes.
Good. These questions are going to take you guys time and take you showing your work. But if you do it, Like this question would be worth like 4 points because there's 4 separate questions. But if you did it through your work, you have a chance of losing 4 points, Greg.
I accidentally drawed off the board. Can I write like an arrow to make sure?
Yeah, that's fine. That's fine as long as you're showing your work, okay? All right, number 2. Mr. Porter bought 5 packages of stickers to use in his classroom. There are 175 stickers in each package. Which model could represent the total number of stickers? So we're looking for total. Let's write our equation first. What would be our equation for this? There's 5 rolls of stickers and each has 175. Multiplication, right? Because we would add 175, 175, 175, 175. So we're going to multiply. So it would be 175 times 5. Okay. I see that there is the box method down here, so let's just draw it out so we know exactly what we need to look for. Okay, so we have our equation and we have what we would use for our box method. So let's compare what we have to what the question says. So we're looking at A first. Do we have 5 times 1? No, what do we have?
500.
Yeah, so A is not correct. What about B? We're starting at 0 and it goes to 175. No. If this was supposed to be correct, it would skip count. It would start at 175. So B is not correct. What do you think of C?
Yes.
Yeah, right, Deja? That matches what we have. Good. D? We're skip counting, but what are we starting at? 75. And then we're skip counting 1, 2, 3, 4, 5 times. So does D work? Yeah, D works. Yeah.
Oh, it works because if you add all of them.
Yeah. Well, and there's how many humps? 5. Yep, so D works. What about E? Does E match what we have?
Yes.
Yes. F? No. Okay. So my tip to you is when you get a question like this, draw your equation, draw your box method, so then you can compare. Otherwise, these things, they really trick you up, okay? Okay. Show me 3 when you're ready for 3. Good. Okay. Each student in Mrs. Conroy's class has a box of 48 markers. There are 23 students in the class. Lisa and Eva write the expression below to find out how many markers there are in all. So that means total. Fill in the blanks. So how many kids are there? 23. And they each have how many markers? 48. Okay, so let's write the equation ourselves. It'd be 23 times 48. And then let's show our box method so we have something to compare. Okay. Lisa has 48 times 3. What is she missing? The 2, which represents 2 tens, which we would write 2 tens as 20. Okay? Because if you add the 20 and the 3 together, you get 23. Okay? Let's figure out what Eva's missing. Eva has 3 times 8, right? Check. Something times 40. So, what else gets multiplied by 40? The 3 and the 20. So, the 20 is here. So, what should we put here in this missing blank? 3? Okay, then I'm going to put a check mark here to just represent that we got that one. Okay. Something times 8. What do we have? 8 times 20. So put a check mark there. What's the last one we're missing? 20 times 40. Check mark there. Okay. There was something like this on the last Standards Mastery, and you guys had like a word bank thing down here, but it had like numbers, and you had to like drag them and put them in the correct spot. You remember that question? Yeah. So the easiest way to do that one is show your own box method, and then as you drag up your correct numbers, check them off on your work, okay? Okay? All right, show me 4 when you're ready for number 4. Okay. Cassandra finds this problem using partial products as shown below. So this is what she did. She starts by multiplying the digit in the ones place by the 7. Okay. Cassandra wonders if the product would change if she starts multiplying 7 by the digits in the thousands place. Does that change your partial product? Here, let's do our box method to show this so we have a better understanding. Okay, would it matter if we added, because see how it says the product would be the same because the value of each digit does not matter when calculating the product? Does the value of each digit matter? Yeah. The product would be the same. Remember, product means answer would be the same because the sum means what? To add. Because the sum of the partial products can be added in any order. Can these be added in any order? Yes. It doesn't matter if you add 7 times 3,000 first or 7 times 2 first. It doesn't matter. So our correct answer is going to be B, okay? When you're going through these, pick out keywords. Do you guys have any questions of this question? No. When you get these big questions with lots of words on them, do them part by part, okay? Like we broke down our partial products first. And then we read the question. And then we went down here, okay? Look at each chunk of the problem to help you break it down. Do you guys have any questions on what we just went over? No? Okay. The rest of your packet, guys, we're going to see how it says do Wednesday at the bottom and do Thursday. We're going to do the rest of those pages later this week in class. Or you can also do them for homework. Okay, let me stop the video.